Welcome to the fourth video on the free and open source Godot game engine platformer series. In this video, we are going to concentrate on the overall game flow, and we are going to add checkpoints and respawn of the player. We will be adding a start screen where we will fall back when dead, and a death state when the player falls from a platform. Finally, we will fine-tune some elements in the life of the player and polish some bugs that we were dragging along. We have a lot of ground to cover, so let's dive into Godot. We are going to start with the checkpoints. We will use an approach that is seen in different games, where we will be using a torch that off while the player has not passed through it, and that switches on as soon as the player reached it. For this, let's start to import all the graphics that we will need for this tutorial, the animations for the torch, and the image that we will be using for the start screen. Let's go to our file browser and copy the folder where we have our assets, to the resources folder in our project folder. All the assets for this video will be linked in the description, and the modified files uploaded to our GitHub that you can find on the reference page on our blog. Let's go back to the game view, and we should see Godot importing the new resources. Open the resources folder. Select all the assets. And then in the hierarchy pane, click on the Import tab. Slide down and switch off the filter option that is on. Click on the button Reimport to refresh all the files. If you remember previous lessons, this will make our pixel art sprites to look crispy and not blurred. Let's create a new 2D scene, by choosing New Scene from the Scene menu. In the hierarchy for the new scene, right-click on the default node 2D and select the option Add Child Node. In the search box type Sprite, and select the option Animated Sprite. Click on Create to create the sprite. In the inspector pane, click on the drop-down box named Frames and select the option New Sprite Frames. Below the game view, you should now see the animations options with an empty animation named Default. Double-click on it to edit the name and name it Flame for now. Later on, we will change its name. From the resources files, under the folder for the torch assets, select all the sprites with the flame animation and drag them into the Animations Frames pane. Zoom out the scene view until you see the torch in the center of the screen. On the inspector pane, click on the playing checkbox to activate it. You should now see the torch animation being played. Set the animation speed to some value between 8 to 12 frames per second. In the hierarchy pane, right-click on the animated sprite, and from the menu choose the option Make Root Node. Delete the node 2D. Select the animated sprite and drag it until the base of the torch is on the center of the scene and coordinates 0, 0. Let's now add a trigger to the torch to detect the player and enable the checkpoint feature. For this, click on the add sign on the hierarchy pane, and in the search box type area. Select the Area 2D node. Right-click on it and in the search box type shape. Select the collider shape option and click Create to close and add the shape to our Area 2D node. In the inspector pane, under the shape option, select a new rectangle shape 2D. Resize it to cover the overall torch sprite, but we can size it accordingly to the shape of the sprite that you may have chosen. Let's rename the animated sprite to Torch. Let's add a new animation by clicking on the Add Animation button. Name the new animation Flame Off, and let's rename the existing one to Flame On. Reselect the Flame Off animation and drag on it the Flame Off sprite in the resources file associated with the torch animations. Select the Area 2D node, and then on the inspector pane, under the option collision, click on the three dots button near the mask IDs. Then, select the player mask. This will make our trigger only interact with the player and no other game object. If you want, you can also set it to a specific layer, but in our case, the default layer will be fine for now. Let's now code the behavior of the checkpoint. Select the Torch root node and click on the button Add Script. Name it Torch and click the button Create. Select again the Area 2D node in the hierarchy, and in the inspector pane, click on the Node tab to select the signals that will be associated with the trigger. Select the body entered, which will be generated when a rigid body will enter the area, and then click the Create button. Click the button Connect to continue, and Godot will create the code associated with the trigger body entered. Save the scene as Torch checkpoint, and before adding code to the function, let's create a new script that we will use to hold the value of the position associated with the checkpoint. Since this value needs to be kept even if we have to restart the scene or reload another one, we will have to use some type of persistency of the data. In Godot, this is achieved by autoloads, which are special scripts that run independently of the structure of the scenes. To create an autoload, we need first to create a new script, and let's name it checkpoint. Delete all the code except the first line with the extend statement. Create a new variable name last position and set it to an initial value of null. This will allow us to know if the checkpoint has been activated or not. For this, in the top menu, click on the Project menu. Next, on Project Settings. Then in the new window, click on the Auto Load tab. Click on the new Auto Load icon, which is after the path field. Select the checkpoint script and then click Open. Next, click the Add button to include the checkpoint, the script to the Autoload feature. Now, we can continue with the coding of our checkpoint. Let's start with the main game script that is executed when the game starts. Let's add the reference to the predefined Godot function enter tree, which will be ran before any other function, even the ready function, when the scene is added to the game structure. Inside, let's check if the checkpoint's last position is set, which means that it is holding a position. That position will be the last position of the player when touching the checkpoint trigger, so let's change the player's global position to this new position. In the torch script in the function associated with the signal on body entered, let's save on the checkpoint's last position the value of the checkpoint position. Let's also show the player that the checkpoint has been active by setting its animation to the flame on with the animated sprite play method. Let's save the project. And then let's drag some checkpoints to the game level. Resize it to a more convenient size. Let's run the game. And let's test the checkpoint and we have an error. It seems to be associated with playing the animation. Let's check the code. Okay. The error is because since we are running the script on the animated sprite itself, we don't need a reference and can directly call the play function. Let's take the opportunity to add the ready function, the reset of the torch animation to the flame off. Let's run again the game, and okay, the checkpoint is switching on when we passed over it. Of course, it is only visual, because if we die, nothing happens. After all, we didn't code it yet. Let's do it, but first, let's duplicate the checkpoint and place it anywhere on the level. Let's go to the player script, and let's go to the dead state execution. After the last instruction and before the pass, let's add the instruction get tree reload current scene. This will make Godot reinitialize the overall scene and all the data associated with it, except for the autoloads that will keep persistently the last data added. Let's run the game and see if the player is sent to the last checkpoint when killed. And the answer is affirmative. But we still have a problem. If we fall from the platform, then we are heading for an infinite fall. Let's fix it now. To kill the player once he fell below a certain point in the level, we will need to use an area 2D, so let's create one. Under it, let's add a collision shape 2D. And under the shape option, let's define it as rectangle shape. Let's click on the rectangle shape, and in the new options that appear below it, let's set the X extents to a large value, as we will want to cover the entire level. Let's select the area 2D node and zoom out to have an overall view of the level. Let's drag the trigger to be under the lowest part of the map. Let's scale it 2 on the x-axis to guarantee that it fills the entire level. With the area 2D selected, and under the collision, as we have done previously for the checkpoint, let's set the mask to player as we want it to only react to the player. We wouldn't want to reset the level in an enemy fell from a platform, wouldn't we? Next, select the Node tab, choose the On-Body Entered Signal function and click on the button Connect. Make sure the game node is selected as we want the function to be created in the same script like the others, and click Connect. In the function created, let's add the same function as when the player died. Get tree reload current scene. Later on, we will add some damage to the process of falling from the platform. Run the game and jump out of the platform and you are correctly respawned on the last checkpoint. But we have a small problem, that we are not able to see if we don't get some damage first. Let's go to the enemy and let's get some damage before falling from the platform. As you can see, falling from the platform refills our life. This is because life is reset each we reload the game. So we need to be able to save the value of the lives between levels reloads or we would be constantly recovering. At this moment, this wouldn't probably be too much of a problem because we only have the life bar, but later on we will add the number of lives, and we will need them to be consistent across all the game. This means that we need to have the player life defined also as an autoload. So, let's define a new script and name it globals. Inside, remove all the code and add 2 variables. Lives that we will set to 3. And life level that we are setting as 100, the same number that we have defined for the player. Now, Let's add the global script to the autoload section of the project setting as we have done for the checkpoint. Go back to the main game script, and under the entree function, let's set the player life to the global life level. This will make sure that the player life will be recovered to the previous value hold on the global life level. Now, in the player script take damage function, every time the player takes a hit, let's update also the global live level to the new player life to keep it updated. And we have an error. It seems that we have misspelled the life level variable. Let's run the game. Let's take some damage and fall from the platform and now the life level is correctly kept. Until we have no more life level, at which time we should stop the game and exit it, or go back to a starting screen. But we don't have one yet. So let's do this next. So let's go back to the main game script. And on the enter tree function, let's test if the life level is below or equal to 0. In which case we will not reload the scene, but rather go to the start scene with the function getTreeChangeScene. Let's add the reference to the name of the start screen scene that we have not yet created, but that we will do next with the name Start Game. Let's create a new empty scene of type user interface. It will create a scene with a control node to hold all the user interface functions. Under it, let's add a sprite node. And from the resources that we have imported at the beginning of the video, let's drag the start screen background onto the sprite node. When prompted for a type, select texture. We should have now our background image in the center of the scene. Let's add now some buttons for the different options that we set in the game: Start Game, Options, and Quit. So, let's add to the control node a new node. In the search box let's type VBox and from the list select the VBox container. This will group our buttons and help us place them where we want on the screen. To the new VBox container let's add a new node of type button. In the inspector pane under the text option, let's name it Start Game. Let's double click on the button to edit the name to Start Game 2. Right click on the node and select the option Duplicate. You can also use the shortcut Ctrl-D. Duplicate the button twice and repeat the previous actions to create the options and quit buttons. Next, select the VBox container and in the Scene View menu under the option Layout, select where you want the VBox to be on the screen. We will choose the options to be on the middle of the screen. Drag the sprite to cover the full screen. Let's save the scene as Start Game as it has been the name that we have used in the Change Scene function. Now let's check how it looks. Since it is not yet the default scene, to see the start scene we need to use the Play Scene button on the top menu, or by pressing the F6 key instead of the Run button that would run the game itself. And we can see for the first time our start screen. Of course without any logic behind it, as we have not yet connected the buttons to any function. Let's do it now. Let's select the VBox container and let's click on the Add Script button on the hierarchy pane header. Name the new script Start menu and click on the Create button. Delete all the code except for the first line with the extend statement. Select the Start Game button, and in the Inspector pane header, click on the Node tab. From the list of signal functions, choose the button Press Signal, and click on the Connect button. As a disclaimer, while editing the video we have seen that the video recorder software was cutting the bottom of the screen. We are sorry for that, but we think that with our comments it shouldn't represent a big problem. Check if the VBox container is selected and click again on the Connect button. In the new function, let's load the game scene by adding Get Tree, Change Scene. After which you can either type the name of the scene you want to load or by dragging the actual scene from the project folder into the function itself. Let's shift to the scene view to be sure that we are still on the start game scene. And let's play it by using the F6 key or by pressing the button Play Scene. Click on the Start button and you should go to the game. If you die, you should go back to the last checkpoint, and if you have the life level fully depleted you should go back to the start game scene. Everything seems to be working correctly. Since for the moment, we will not have an options screen, let's implement the Quit button. Repeat the steps that we have done for the Start button. And in the Quit button pressed function, let's add the code Get Tree Quit function. This should quit the overall program and exit the game. Let's quickly check it by playing the scene and clicking on the Quit button, which should end the game. Let's fine-tune some of the functionalities that we have added. When the player fell from a platform, no damage is associated with it, so it would be free for the player. Let's do some small damage to it. So, let's go to the main game script. And in the function associated with the player falling out of the game, let's remove some life level to the player, like for example 10. Let's save the value on the global life level. We have again a typo. Let's add the I to the live level variable name. Let's run the game. And we fall from the platform, we can see that the life level of the player is being depleted. We have another small bug in the game. If we run the game and get some damage until being sent back to the start screen, we will see that we are not able to get back into the game. This is because, when you lose all the life and are sent back to the start screen, the global life level is still 0, and that means that when we try to get back in, since the life is below or equal to 0, we are resent the start screen. To fix it, we just need to reset the global live level to 100. For this, on the main game enter tree function, before sending the player to the start screen, let's set back the global life level to 100. Let's run the game again and take enough damage to go back to the start screen. And it is working. We can restart the game, in this case right from the last checkpoint, but we could change it later on if we want. Until now, we have just been playing around with life level, but we want also our player to have 3 lives, after which he will no longer be respawned in the last checkpoint but sent back to the start menu. Let's start by importing the sprites that we need for it. So from our local folder, let's copy the new sprite sheet onto the resources folder in our project folder under the GD health bar. Go back to Godot, and in the import options for the new sprite, switch off the filter option. Re-import the sprite to apply the options. Let's go back to the game view and in the hierarchy pane, look for the UI node. Under the control node, add a new node of type sprite. From the project folder, drag the new life image on top of the newly created sprite. When prompted, select the type texture. Zoom down on the game view until the UI becomes visible. You can see the new file on top of the life level with all the sprites visible. In the inspector pane, click on the animation options, and then on the frame. Increase the number from 1 to 4, as to see only one row of the sprite sheet. Now, on the frame input field, set the number to 3, and you should see now 3 filled hearts. If you play around with the frame number, you can see that we can change the number of hearts filled, size and place the life UI accordingly to your needs. Right-click on the sprite node, and rename it to Player Lives. Let's implement now the basic functionality. Let's go to the main game script, and on the top of it, let's get the reference to the sprite by calling the getNode function in the path to the new sprite player lives and save the result on the variable life UI. Next, in the enter tree function, under the line where we are checking if the life level is below 0, let's a new if statement, where we will be checking if the variable lives is bigger than 0, in which case, we will reset the life level to 100. And we will decrease the number of lives by 1. Else, if not, then we will change to the start game scene. After that, we need to make sure that the number of lives is always refreshed, so in the ready function, let's set the frame value of the life UI to the number of lives the player currently has. Let's run the game, and let's try to lose some lives. It is quite tedious as the penalty of falling from the platform is too low. But, after a couple of attempts, we can see that the player loses correctly the number of lives represented by the number of hearts filled. We think that we should improve it. Let's make the player lose a full life when falling from the platform. So, in the main game function associated with falling from the platform, let's reset the player life to its maximum. And let's decrease the global's lives by 1. Let's run the game to see if it is better now. Yes, it is working, but after 3 falls the system stopped working and allows for infinite lives. Let's fix it. In the main game script, let's go to the enter tree, and before the line where we check the life level, let's check if the number of lives is smaller or equal to 0. If it is the case, then let's send the player to the start screen. Let's run the game. And after 3 falls from the platform, we are sent back to the start screen. Great! But we cannot restart the game again. We have already seen a very similar problem. Let's fix it. In the new block of code that you have added, let's set the life levels and the number of lives of the player to their original values, as the player is starting over the game. Let's run the game. And let's become again a lemming jumping out of platforms. And everything works correctly. Let's try a full run right from the start screen. Well, everything seems to work correctly with the game flow. But when we are fighting the enemy we still have that boring bug of the player's knockback that is not yet always sending the player in the correct direction. Let's take the opportunity to solve it once for all. In the player script, under the take damage function, let's implement some changes. We will be receiving the direction from where the enemy was coming as to push the player in the opposite direction. Let's go to the top of the player script, and let's add a new variable knockback dir that we will set to false. Now, back in the take damage function, let's set the value of the knockback dir with the value that we are receiving from in the parameters of the function, and that will be referring if the enemy was going left or right when he attacked us. Next, let's go to the hurt state. And in the knockback code, let's replace the variable moving right by the knockback dir. After that, let's go to the enemy script. Under the function the signal function associated with the hitbox of the enemy, let's add to the take damage function parameters the current direction of the enemy represented by the variable moving right. Let's run the game and let's see if the problem is solved. Well, no. The player is going in the wrong direction of the knockback and not away from the enemy but right into it. Let's go back to the player script and the hurt state. Invert the signs of the knockback strength. Let's run the game again. And everything is running correctly. In the next episode, we will add moving platforms, doors, and keys to increase the complexity of the level that you could be creating. We hope that you have liked this video. If it has been the case, consider subscribing, giving a like, and clicking on the notification button. If you have any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.